Namaste, Vanakkam, and a warm welcome back to you to your very own YouTube channel, Midhaguru. It's me, Manan, the maths faculty here. So today, the video lesson I have brought for you is the solutions of exercise 5D and 5E from the textbook Selina Concise Mathematics, chapter 5, that is Quadratic Equation. So in this chapter or in this video lesson, we will be seeing how to deal with problems when you are supposed to solve them with the help of the quadratic formula and not by factorization. So we'll see different types of applications of this quadratic formula on how to solve different types of quadratic equations. So stay tuned till the end of the video and let's begin. So before we get into the solutions of the exercise, let us first see how we can calculate the square roots. That is, we can see the square roots from the square root table that is at the last page of your book, or that the one that you will be provided in your exams. So as you can see, we have the square roots from 1 to 10. So for example, let us say the discriminant comes to be 2.5 and we need to take out the square root. So instead of wasting your time in calculating it, you are allowed to check from this square root table. So let us say the discriminant is 2.50. We have to see like this, it is 2.5 here. So 2.50, the square root of 2.50 will be 1.581. That of 2.51 would be 1.584. Similarly, let us say the discriminant was 2.57. So 2.5 and in 7, we see the square root to be 1.603. So this is how we will see the square root tables to calculate the square root of the discriminant that we want. Let us say the discriminant is 4.18. So we see the 4.1 line, we see it is here. So the square root of 4.18 will be 2.045. Now similarly, if we see the square roots of 10 to 100, let us say we have to, discriminant comes to be 40.9. So we have 40 here in this line and 40.9 will be 6.395. Similarly, if it says 27.7, so we see the line of 27 here and 0.7 is over here. The value will be 5.263. This is how we will see the square root tables to get the values for the square root of the discriminant. And we will use those values to solve our equations. So now let's move on to the exercise now that we have learned how to see the square roots from the square root table. Now that we have seen how to calculate the values, that is square root values from square root tables, let's try and start solving problems using the quadratic formula. So we'll start with exercise 5D. The first question being, solve the following equations by the quadratic formula. So we'll have a row of equations and we'll solve one by one by using the quadratic formula. So again, just to keep in mind, to solve by this method, we have to remember that the equation is of the form ax square plus bx plus c. That is, we have to try and write this equation down in the standard form. Then we'll take the values of a, b, c to determine the determinant, and then we'll use it in the quadratic formula. If you don't know this concept, it means you haven't watched the video, that is the basics of quadratic equations. So please go down to our channel in the description and watch that video, as it will help you understand how to solve equations using the quadratic formula. Also, if you haven't watched, that is the solutions of exercise 5A, 5B and 5C, please go down to the link in the description and watch that video as well. Coming back to our problem. So it is given x square minus 6x is equal to 27. In the standard form, we'll write that down as x square minus 6x minus 27 is equal to 0. Then, so if nothing is written, it means a. So a is 1, b is minus 6 and c is minus 27. So now we'll calculate the determinant. The formula for the determinant is b square minus 4ac. So b square, that is minus 6 squared minus 4 into a is 1 into minus 27. So we'll get 36. Minus and minus will become plus. 37 into 4, 80 plus 28. This will be equal to 144. Now we'll apply this value of d into the quadratic formula, which is that x is equal to, just a second, minus of b plus minus the root of the discriminant divided by twice of a. So now we'll apply these values as it is. So we have minus of b, b was minus 6, so minus of b will become 6, plus or minus the root of the determinant, that is 144, divided by twice of a. Since a is 1, we'll just divide it by 2. So now we know the root of 144 is 12. So we'll write x is equal to 6 plus or minus 12 divided by 2, which means x is either equal to 18 by 2 or x is equal to minus 6 by 2. So x will either be equal to 9 or x will be equal to minus 3. So these are the solutions for the given equation. This is how we are supposed to solve quadratic equations with the help of the quadratic formula. So let's just start solving these problems together. As I always say, if you feel like you're confident enough that you can solve it by yourself, pause the video here and try a few problems for yourself. Then you can watch the video as a solution, that is to check your answers. If you can't, then let's start together. So now the second question is x square minus 10x plus 21 is equal to 0. Here, as you can see, we don't need to arrange it in the standard form because it is already arranged in the standard form, that is ax square plus bx plus c. So from here, we'll just write that since there is nothing beside x square, a is equal to 1, b is minus 10 and c is equal to 21. Now we know that first we have to calculate the discriminant. So the discriminant is nothing but b square minus 4ac. So b is minus 10. So minus 10 whole squared minus 4 into a is 1 and c is 21. So we'll get 100 minus 84, which is 60. So the discriminant is nothing but 60. Now we'll use our quadratic formula, that is minus b plus or minus the root of d divided by twice of a. So we'll just substitute all these values. Now since b is minus 10, minus of b will become 10 plus or minus the root of 16 divided by 2a, and a nothing being 1, then divided by 2. So we'll get x is equal to, now since we know that the root of 16 is 4, we'll write 10 plus or minus 4 divided by 2. So now x is either equal to 10 minus 4 by 2, that is 6 by 2, or 10 plus 4 by 2, that is 14 by 2. So x will be equal to 3 or x will be equal to 7, right? So now let's move on to the next question. So in the next question, the equation is x square plus 6x minus 10 is equal to 0. Again, it is already arranged in the standard form. So we'll directly take away the values of a 1, b is 6 and c is minus 10. So we know that the discriminant is b square minus 4ac. So the discriminant will become b squared, that is 6 squared, minus 4 into a is 1, c is minus 10. 6 squared will be 36, and since minus and minus becomes plus, it is 4 into 10, that is 40. So we get 76. So the discriminant is 76. Now again, coming back to the quadratic formula. So we'll write x is equal to, now since b is 6, minus b will become minus 6, plus or minus the root of the discriminant 76 divided by twice of a, and a nothing being 1 will be 2. Now see, in the earlier problems, we had perfect squares under the discriminant, that was 144, which is the square of 12, and 36 here in the earlier problem, 16 sorry, which is the square of 4. Here however, we don't have a perfect square under the square root. So again, we will go back to our square root tables that we learnt about earlier, and we'll see what the value of square root 76 is. So here we'll see that I have my book right here. So the square root says 76 is 8.77. So we'll write minus 6 plus or minus 8.77. Now an important thing to remember here is, unless and until the question doesn't say that you are supposed to take 2 decimal places or 3 decimal places, it is always good to remember that we can just take 2 decimal places and our answer will always be right. Anyway, so now we have to do that x is minus 6 plus 8.77, which will be 2.77 divided by 2, or x is minus 6 minus 8.77, which will be equal to minus 14.77 by 2. So now x is either equal to 1.5 or x is equal to 7.385. I'm sorry, minus 7.385. So rounding off to 2 digits, we will get 1.39, or x is equal to minus 7.39. Now these will be the values for x, that is the solutions for this given equation. Now let's move on to the next problem. Now the next equation is x square plus 2x minus 6 is equal to 0. Again, since it's already in the standard form, let's just take away the values of a, b and c, that is a is 1, b is 2 and c is equal to minus of 6. So now coming back to the discriminant, we have d is equal to b square minus 4 times of ac. So d will be equal to b squared, that is 2 squared, minus 4 into, that is a is 1, into c, that is 6. Oh, sorry, minus 6. So d will be equal to 4. Now since minus minus becomes plus, and this will become 24. So d is equal to 28. Now again coming back to the quadratic formula, it is x is equal to minus b plus or minus the root of d divided by 2a. So we'll just substitute all the values. Now since b is 2, so minus of 2 will be minus 2 and the root of 28 divided by twice of a, and a nothing being 1, so the root will be 2a will be 2. So now again we don't know the root of 28, that is we don't know the perfect root of 28. So going back to our square root table, we have 5.29. So we will say x is equal to minus 2 plus or minus 5.29 divided by 2. So x will either equal to minus 2 plus 5.29, which will be equal to 3.29 divided by 2, or x will be equal to minus 2 minus 5.29, which will be minus 7.29 divided by 2. So x will be equal to 1.645, or x will be equal to 3 point, sorry, just a second, minus 3.645. So x will be equal to either 1.65 or x will be equal to minus 3.65, since we rounded it off to 2 digits. So this is how we find the solutions for the given equation. So let's move on to the next problem. Now the next equation, 3x square plus 2x minus 1 is equal to 0. Again, since it's already in the standard form, you can just directly take the values of a to be 3, b as 2 and c is minus 1. Now the discriminant is b square minus 4 ac. So we'll just substitute the values of b, a and c. So b is 2, which is 2 squared, minus 4 into a being 3 and c being minus 1. So it is 4, minus and minus becomes plus 12. So the discriminant is equal to 16. Now x is equal to minus of b plus or minus the root of the discriminant divided by twice of a. So x is equal to minus of b, that is minus 2, plus or minus the root of 16 divided by twice of a, which is nothing but 3, so 2 into 3. So x is equal to, now the root of 16 will be 4. So minus 2 plus or minus 4 by 6. So x is equal to minus 2 plus 4, which will be 2 by 6, or x is equal to minus 2 minus 4, which will be minus 6 by 6. So x is either equal to 1 by 3 or x is equal to minus 1. And these are the roots for the given quadratic equation. Moving on to the next problem. Now the next equation is 2x square plus 7x plus 5 is equal to 0. Now since this is also in the standard form, we'll just take the values of a, b and c. A is 2, b is 7 and c is 5. So all of them are positive. Now the discriminant we know is b square minus 4ac. So now b is 7, so b squared will be 49 minus 4 into a being 2 and c being 5. So we have 49 minus 4 into 2, 8 into 5, 40 is equal to 9. So the discriminant is 9. Now coming back to the quadratic formula, which is minus b plus or minus the root of d divided by 2a. So b is 7, so minus of 7 plus or minus the root of this discriminant divided by twice of a, that is 2 into 2. So x is equal to minus 7 plus or minus, now since d is, oh I didn't write it here, sorry, 9. Since the discriminant is 9, we know it's a perfect square, that is the root of 3, the square root being 3, divided by 2 into 2, which is 4. So one value will be minus 7 plus 3, which will be x is equal to minus 4 by 4. Or the other value is minus 7 minus 3, which will be minus 10, so minus 10 by 4. So x is equal to either minus 1 or x is equal to minus 2.5. Just correct that a little bit. So x is either equal to minus 1 or minus 2.5, and those are the solutions for the given quadratic equation. Now let's move on to the next problem. Now the next equation is 2 by 3x is equal to minus 1 by 6x squared minus 1 by 3. Now there are two ways of going about this problem. We can either just shift them all to one side of the equation, get the values of a, b and c directly, or we can remove this fraction part by taking the LCM. So first things first, what we will do is we will take all the terms to one side. We will get 1 by 6 x square plus 2 by 3x plus 1 by 3 is equal to 0. Since these both are negative terms and they go to the other side and become positive. Now clearly the LCM will be 6. The LCM of the denominator is 6. So x squared plus, since this is 3 it becomes 4x, and again it's 3 it becomes 2 is equal to 0. I take 6 to this side, I get x squared plus 4x plus 2 is equal to 0. So now from this equation, now that it is in the standard form, we can take a as 1, b as 4 and c as 2. Now again d is b squared, that is 4 squared, which is 16, minus 4 times of a into c. So 16 minus 8, which is 8. So the discriminant is 8. Now again the quadratic formula is minus of b plus or minus the root of the discriminant divided by 2a. So x will be equal to minus b, that is minus 4, plus or minus the root of 8 divided by 2a, a being nothing but 1, become 2. So x is equal to minus 4 plus or minus. Now again 8 is not a perfect square. So again I go back to my square root tables. I get the square root of 8 is 2.82. Now this divided by 2. So x will either be equal to minus 4 plus 2.82, which will be equal to minus 18 by 2, or x is going to be equal to 2.8 minus 4 minus 2.82, which will be minus 6.82 by 2. So this will become x is equal to minus 0.59 or x is equal to minus 3.41, and these are the solutions for the given quadratic equation. Let's move on to the next problem. The next equation is 1 by 15x square plus 5 by 3 is equal to 2 by 3x. Like the earlier problem, we can start solving right away by bringing all of them together, taking a as 1 by 15, since this comes it becomes b is minus 2 by 3 and c as 5 by 3, or we can take the LCM, remove that denominator from all the fractions and then see the equation in the standard form. So first I'll bring this term, that is 2 by 3x, to the other side. The equation becomes 1 by 15 x squared minus 2 by 3 x plus 5 by 3 is equal to 0. Clearly the LCM of the denominators is 15. So x squared, now 3 into 5, which means 2 also has to be multiplied by 5, so 10x, and 5 into 5 will be 25 is equal to 0. So x squared minus 10x plus 25 is equal to 0. Now the equation is in the standard form. So a is equal to 1, b is equal to minus 10 and c is equal to 25. Now the discriminant is b squared, so minus 10 squared minus 4 into a, that is 1, and c, that is 25. So minus 10 squared will be 100 and 4 into 25 will also be 100, which comes to 0. So now if you remember the concepts that we learnt about quadratic equations, we learned something that is known as the nature of the roots. How straight away, just by looking at the discriminant, we can decide what the roots or what the nature of the roots of quadratic equation is going to be. If you remember well, when the discriminant is 0, quadratic equation has two equal and real roots. How that comes about will be clear when we substitute the values in the quadratic equation, which is minus b plus or minus the root of 10 divided by twice of a. Now if we just substitute minus b, b is 10 minus 10, so it becomes 10 plus or minus, since d is 0, the root of 0 divided by 2 into a, which is nothing but 2. So x is equal to the root of 0, we'll take it as 0. So it will become x is equal to 10 by 2. And both the roots of x are 5. Now this makes sense because we learned that if the discriminant is 0, the roots are real and equal. So both the roots of this equation are only 5, right? Okay, so let's move on to the next problem. The next equation is x square minus 6 is equal to 2 root 2 x. To bring it into the standard form, I'll just shift this term to the other side. It becomes x square minus 2 root 2 x minus 6 is equal to 0. So now a is 1, b is minus of 2 root 2 and c is minus 6. So now d is b squared, so 2 root 2 whole squared minus 4 times of ac, a being 1 and c being minus 6. So we have minus 2 root 2 whole squared, which will be 8, and minus and this minus becomes plus, so 4 into 6, which is 24. This gives us 32. So the discriminant is 32. Now we'll put it in the quadratic equation, that is the quadratic formula. So x is equal to minus b plus or minus root d by 2. So x is equal to minus of b. Now since b is 2 root 2, minus 2 root 2. So minus of minus 2 root 2 will become 2 root 2 plus or minus the root of 32, which will be divided by 2a, a being 1 divided by 2. So x is 2 root 2. Now since we do not know the value of root 32, but I know that I can try and write it as, since 16 into 2, 32 is 16 into 2, I can write it as 4 root 2 divided by 2. So x is either equal to 2 root 2 plus 4 root 2, which is 6 root 2 divided by 2, or x is equal to 2 root 2 minus 4 root 2, which is minus 2 root 2 divided by 2. So now x is equal to 6 root 2 divided by 2, and the value of root 2 is 1.41. So 6 into 1.41 by 2, or x is equal to minus 2 into 1.41 divided by 2. This 2 gets cancelled out. So we have x is equal to 4.23, or x is equal to minus 1.4. And these are the solutions for the given quadratic equation. Moving on to the next problem. Now, next equation is 4 by x minus 3 is equal to 5 by 2x plus 3. So first what we will do is, we will bring it into the standard form. So for that, we will bring all the terms to one side of the equation. So we have 4 by x minus 3, which you can write as 3 by 1, minus 5 by 2x plus 3 is equal to 0. So now we will take the LCM as x into 2x plus 3. So now since x is already present here, this will become 4 into 2x plus 3 minus 3 times of x into 2x plus 3 minus 5 into x, which will be equal to 0. So if we take this term to the other side, it will become 0 as well. So this will become 8x plus 12 minus 3 into, inside this bracket we will get 2x squared plus 3x minus 5x is equal to 0. You can write as 8x plus 12 minus 6x squared minus 9x minus 5x is equal to 0. Adding all the x's together, we will get minus x minus 6x minus 6x squared minus 6x plus 12 is equal to 0. Now we will divide this entire equation by minus 6 and we will get x squared plus x minus 2 is equal to 0. Now from this, as it is in the standard form, we will get that a is equal to 1, b is equal to 1 and c is equal to minus of 2. So the discriminant will be equal to b squared, that is 1 squared, minus 4 times of a into c. So you will get 1, minus and minus becomes plus, 4 into 2 is 8 equal to 9. So the discriminant is equal to 9. Now we will put it in the formula, x is equal to minus b plus or minus the root of discriminant by 2 times of a. So just by substituting, you get minus of 1 is minus 1 plus or minus the root of 9 divided by 2a, a being 1, 2. So the root of 9 will be 3. So x will be equal to minus 1 plus or minus 3 divided by 2. So x is either equal to minus 1 plus 3, which will be 2 by 2, or x is equal to minus 1 minus 3, which will become minus 4 by 2. So x will be equal to 1 or x is equal to minus of 2. So these will be the solutions for the given equation. Now let us see the next problem. The next question is 2x plus 3 by x plus 3 is equal to x plus 4 by x plus 2. So again, first step will be just to bring this into the standard form. For that, what we will do is we will cross multiply x plus 2 here and x plus 3 there. We get 2x plus 3 into x plus 2 is equal to x plus 4 into x plus 3. So we will get 2x squared plus 4x plus 3x plus 6 equal to x squared plus 3x plus 4x plus 2. Now if you look on both sides of the equation, we have plus 4x and plus 3x, so we will cancel that out. Now we will take 6 to the other side and x squared here. We will get 2x squared minus x squared. X squared is equal to 12 minus 6, 6. This became our equation. So we don't even need to solve it. If we know the root of 6, we can directly answer this question. For that, again I go back to my square root tables, and we have that the square root of 6 is 2.449, which we will take as 2.45. So x squared is equal to the square of 2.45 plus or minus. So x will be equal to either plus or minus 2.45, which means x is either equal to 2.45 or x is equal to minus 2.45. So these will be the solutions for the given equation. See, we did not use the quadratic formula here because we did not need to use it. Sometimes the equation may land up such that we have a value of only x square and a constant value. So we can directly evaluate them to get the solutions for our given equation. Let's move on to the next problem. Now the next equation is root 6x square minus 4x minus 2 root 6 is equal to 0. Again here we don't even need to put it in the standard form because it already is in the form x square plus bx plus c. So what we are going to do is we will directly take the values of a, b and c. A will be equal to root 6, b will be minus 4 and c will be minus 2 root 6. From here we can say that d is b square, which will be minus 4 squared minus of 4 into a being root 6, c being minus 2 root 6. So 4 squared will be 16, and minus will become plus, and we have inside 4 into 2 and root 6 into root 6 becomes 6. So now we have 4 into 2, 8 into 6, 48. So the discriminant is equal to 64. Now we come to the quadratic formula, that is minus of b plus minus root over the discriminant by 2 times of a. They will get x is equal to minus of b. Now since b is minus 4, it becomes 4 plus or minus the root of the discriminant, that is 64, divided by twice of a, which is twice of root 6. Now we have x is equal to 4 plus or minus, since root 64 is 8, we will write down 8 by 2 root 6. So x 4 plus 8 will be 12 by 2 root 6, you can cut that to be 6, or 4 minus 8 will be minus 4 by 2 root 6. And then 6 by root 6 will become root 6, or x is equal to minus 2 by root 6. Now since root 6 is 2.45, x is either equal to 2.45 or x is equal to minus 2 by 2.45. So this value is the same, we don't need to change it. So the values of x will be 2.45 or minus 0.81. Okay, let's move on to the next problem. Now the next question is 2x by x minus 4 plus 2x minus 5 by x minus 3 is equal to 81 by 3. Again, before we do anything else, the first thing we need to do is bring it in the standard form. So let's go about it. So clearly on the left hand side, the LCM will be x minus 4 into x minus 3. So x minus 4 into x minus 3, and here if we solve it, it is 25 by 3. We let that stay right now. So it will become 2x into x minus 3 plus 2x minus 5 into x minus 4. Now we have 2x squared minus 6x plus 2x squared minus 8x minus 5x plus 20 by x squared minus 7x plus 12 is equal to 25 by 3. Now, once we equate this, whatever this is equal to, we'll multiply 3 up here and we'll multiply this entire term here. So, we'll get 2x squared plus 2x squared is 3 into 4x squared, 2x squared plus 2x is 4x squared minus 6 minus 8 minus 14 minus 15 minus 19x 13 6, okay, plus 20 is equal to 25 into x squared minus 7x plus 12. Again, when I open the bracket, it becomes 12x squared minus 57x plus 60 is equal to 25x squared minus 175x plus 300. Now, bringing all the terms to any one side of the equation, we get the new equation as 13x squared minus 118x and 240. So, this is our final equation in the standard form, which means A is equal to 13, B is equal to minus 118 and C is equal to 240. Now we can start solving by finding the discriminant first, which is 118 minus 118 squared minus 4 times of 18 into 240. The discriminant will be equal to 4, 12 minus 8 is 4, 1. So our discriminant is equal to 1444. Now just to put it in the equation, it will become minus b plus or minus the root of d by twice of a, which means x is equal to minus and minus becomes plus, plus 118 square root of 1444 divided by 2 into 30. So x will be equal to plus square root of 118. Now I don't know the square root of 1444. So what we will do is we will just prime factorize it here quickly. Let's see if we can get some logical square root for it. 2, 3, 6, 1. 3 plus 6, 9 plus 61 is 19. 1, 17 and 21. 10 is 2 into 19. So the square root of 1420 is 38 divided by 2 into 13, that is 26. So x is either equal to 118 minus 38, which will be 80 by 26, or it is equal to 118 plus 38, which will be equal to, let me see, 6, carry 1, 5. Which means x is equal to, 3.0, so it is 3.01, or x is equal to 156 by 26, which we can equate as 13 into 78, will go 6 times. So x is either equal to 3 or x is equal to 6. These are the roots for the given quadratic equation. The mathematics here may seem to be a little bit complex, as we have a huge number to take out the square root. We have to do lots of calculation to get it to the standard form, but don't worry, it's quite easy if you get a hang of it. If you do lots of practice of these type of problems, it will not be an issue. So let's move on to the next problem. Now the next question is x minus 1 by x minus 2 plus x minus 3 by x minus 4 is equal to 3, 1 by 3. This is quite similar to the problem we solved earlier, so we'll do it in a similar fashion as well. From here we can write x minus 1 into x minus 4 plus x minus 3 into x minus 2 is equal to 3. This is 10 by 3 here. Here I did nothing, I just took the LCM as x minus 2 into x minus 4. So again we have x squared minus 5x plus 4 plus x squared minus 5x plus 6 by x squared minus 6x plus 8 is equal to 10 by 3. So we multiply this 3 here and we take this to the other side. We get 3 into, this becomes 2x squared minus 10x plus 10 is equal to 10 into x squared minus 6x plus 8. So we get 6x squared minus 30x plus 30 is equal to 10x squared minus 60x plus 80. Now again we'll bring all the terms to any one side of the equation. We get 4x squared minus 30x plus 50 is equal to 0. We can divide this entire equation by 2. We'll get 2x squared minus 15x plus 25 is equal to 0. Now we'll solve. We'll say that a is equal to 2, b is equal to minus 15, c is equal to 25. Now to find the discriminant, we have b squared, that is minus 15 whole squared, minus 4 into a into c, which is 15 squared is 225 minus 4 into 8 into 25 is 200, which you get 25. So the discriminant is 25. Now to solve, put in the quadratic formula and then we just substitute the values of b, d and a. So we get minus of minus 15, which will become 15, plus or minus the root of 25 divided by twice of a, which will become 2 into 2, that is 4. So we have x is equal to 15 plus or minus the root of 25 being 5, we write down here 5 by 4. So we have x is equal to 15 minus 5, that is 10 by 4, or 15 plus 5, which is 20 by 4. So x is either equal to 2.5 or x is equal to 5. So these will be the solutions for the given quadratic equation. So moving on to the next problem now. Now we come to the second question, which says solve each of the following for x and give in each case your answer correct to 1 decimal place. So whatever our answer comes to in the end, we'll round it off to 1 decimal place. So the first one is x square minus 8x plus 5 is equal to 0. Again here we don't need to put it in the standard form, it already exists. So we'll just say a is equal to 1, b is equal to minus 8 and c is equal to 5. Here we can calculate the discriminant as the square of b, that is minus 8, minus 4 into a being 1 and c being 5. We have the square of 8 is 64 and 4 into 5 is 20. So we have the discriminant as 44. Now x is equal to minus of b plus or minus the root of the discriminant divided by twice of a. So x will be equal to minus of minus 8, which is 8, plus minus the root of 44 divided by 2 into 1, which is 2. So now x is equal to 8 plus or minus. Now again, since 44 is not a perfect square, we go back to our square root tables, and from here we will find out that the square root of 44 is 6.63. So we write down 6.63 and we divide it by 2. Now 8 minus 6.63 would be equal to 1.37 by 2, or 8 plus 6.63 would be 14.63 by 2, which makes x equal to 0.685, or x is equal to 7.315. Now these two are the solutions for the given equation. But remember, the question says we have to round off our answers correct to 1 decimal place. So we'll round up both of them off to 1 decimal place, from where we'll get that x is equal to 0.7 or x is equal to 7.3. And these will be the answers for our given quadratic equation. Now let's move on to the next problem. Now the next equation is 5x squared plus 10x minus 3 is equal to 0. Let's see how we can solve this. Okay, so a is 5, b is 10, and c is minus 3. Now whether the discriminant is the square of b minus 4 into a into c. So we get 100, and minus becomes plus. 4 into 5, 20 into 3, 60. 160. Or we can write d as 16 into 10. Why I did this separation is so that when we take out the square root, it will be easier, since calculating the square root of 160 will be a tedious job. You don't need to do that. Now that we know 16 is a perfect square, we just need to take out 4 and we need to take out the square root of 10 based on the square root tables. Now we apply this to our quadratic formula. Substituting the values, we get minus 10 since b is 10, and the root of 16 into 10 divided by twice into 5, which is also 10. So now we have x is equal to minus 10 plus or minus 4 into, we have the root of 10. Again, from our square root tables, the root of 10 is 3.16 divided by 10. So now x is either equal to 10 plus, which would be 14.16, sorry, 4 into, I'm so sorry, that is x is equal to minus 10 plus or minus 3.16 into 4, which will be equal to 4, 6 are 4, carry 2, 8, 6, 6 are 2. So this is 12.64 by 10. Now if we subtract, we will get minus 22.64 by 10. Or if we add it, we will get a positive 2.64 by 10. We can write the answer as directly as minus 264 or 0.264. Now since we are supposed to round off to one digit, one decimal place, that is, we'll write it as minus 2.3 or x is equal to 0.3. And these will be the solutions for the given quadratic equation. Let's move on to the next problem. Now next we have the question. Again we are supposed to solve by the quadratic formula, but this time we are to take up to 2 decimal places. So first things first, as you can see, it is already in the standard form. So we'll say that a is equal to 2, b is equal to minus 10 and c is equal to 5. So from this we can say that the discriminant is b squared, that is minus 10 squared, minus 4 times of 2 into 5. So this will be equal to 100 minus 2, 5, 10, 40. So this is equal to 60. So the discriminant is 60. Now we'll apply the quadratic formula. So we have x is equal to minus of b. Since b is minus 10, minus of b will become 10 plus or minus the root of 60 by twice of a, that is 2 into 2. So we have x is equal to 10 plus or minus. Let us see. Now again, 60 is not a perfect square. So we go back to our square root table. Now the root of 60 can be given as 7.75. Just checking once again. 60. Yeah, it is 7.7459. To take 2 decimal places, we can take 7.75. So once it will be 10 plus 7.75, which will become 17.75 by 4. Or it will be 10 minus 7.75, which will be equal to 2.25 by 4. Now dividing both of these, we will get 4.17453. 307, or x is equal to 0.5256. So we have x is equal to 4.473, we can write as 44, or x is equal to 0.56. So we have to solve up to 2 decimal places. Based on that, these are our solutions for the given quadratic equation. Now moving on to the next equation, it is 4x plus 6 by x plus 13 is equal to 0. So since this does not look to be in the standard form, we can either take the LCM as x and do that, or we can simply multiply x to the entire equation. If we multiply x, we will get 4x squared plus x and x will get cancelled. This will become 6, and 13x is equal to 0 into x is 0. So again we will write it as 4x squared plus 13x plus 6 is equal to 0. So a is equal to 4, b is equal to 13, and c is equal to 6. So the discriminant is b square minus 4ac. B square being 169 minus 4 into 4 into 3. So 169 minus 4 into 4 is 16 minus times 3, 48, which will get us 121. So the discriminant is equal to 121. Now, so now x is equal to minus b plus or minus the root of the discriminant by twice of a. You can say x is equal to, since b is 13, minus of 13 plus or minus the root of 121 divided by 2 into 4, since a is 4. So this becomes x is equal to 13 plus or minus. Now since 121 is the square of 11, we can write it as 11 and 2 into 4 is 8. So now minus 13 minus 11 will give us minus 24 by 8, or minus 13 plus 11 will give us minus 2 by 8. So either x is equal to minus 3 or x is equal to minus 0.25. So these are the solutions reduced to 2 decimal places. Since this is a whole number integer, it does not matter, and here it is minus 0.25. So these are our solutions for the given quadratic equation. Let's move on to the next question. Next equation, 4x square minus 5x minus 3. Now since it's already in the standard form, we don't need to do any solving. We'll just take away straight away that a is 4, b is minus 5, c is minus 3. So the discriminant is b squared minus 4 times of a and c. Now since minus 5 is 25 and this minus 3 becomes plus, 16 into 3 is 48. From here we get 3 and 73. So the discriminant is 73. Now, so x is equal to minus b plus or minus the root of d by twice of a. Substituting all the values in this equation, we get b is minus 5, so minus b becomes 5, plus or minus the root of 73, 50, 40, yeah, and twice of a, which is 8. So x is equal to 5 plus or minus. Now again 73 is not a perfect square. So we go back to our table, square root table, and we see that the square root of 73 is equal to 8.54. So now x is either equal to 5 plus 8.54, which will be equal to 13.54, or 5 minus 8.54, which will be equal to minus 3.54. So then we can divide it as so x is either equal to 1.69 or x is equal to minus 0.44, rounded off to 2 decimal figures. So those are the solutions for the given quadratic equation. Moving on to the next equation, we have x square minus 3x minus 9 is equal to 0. So a is equal to 1, b is a minus 3, and c is minus 9. So the discriminant is b squared minus 4 times of a, c. So this is 9 and minus minus becomes plus. 4 into 9 becomes 36. So this is equal to 45. So the discriminant is 45. Then again x is equal to minus of b plus or minus the root of d divided by 2 times of a. Substituting all these values, we get x is equal to minus of b, which will become 3, plus or minus the root of 45 divided by twice of a, which will be, so x is equal to 3 plus or minus. Again we go back to the square root table. The root of 45 is 6.71 divided by 2. Now x plus 6.71 would be 9.71 by 2, and x minus 6.71 would be x is equal to minus 3.71 by 2. And if we divide it by 2, we get 4.17815, or x is equal to minus 1.178. So rounded off to 2 decimal figures, the solution for this quadratic equation is 4.85 and minus 1.85. Now let's move on to the next equation. The next equation is x square minus 5x minus 10 is equal to 0. So a is equal to 1, b is equal to minus 5, and c is equal to minus 10. So the discriminant will be equal to, minus 5 whole squared minus 4 into 1 into minus of 10. So 5 squared becomes 25, and since we have minus and minus, this becomes plus 40. So this is 65. The discriminant is equal to 65. Now x is equal to minus b plus or minus the root of the discriminant divided by twice of a. Since b is minus 5, minus of b becomes 5 plus or minus the root of 65. And since a is 1, we'll write 2. So now x is equal to 5 plus or minus. Going back to our square root tables, we again get the root of 65 to be 8.06 by 2. So 5 plus 8 would be 13.06 by 2, or 5 minus 8 would be minus 3.02 by 2. So the two values for x will be 13 by 06, which will be 6 point, or minus 1.51. So these are the values or the solutions for the given quadratic equation. Let's move on to the next question. So the next question, see, up until now we were doing it, even by default we were doing it only up to 2 decimal places. Then the question asked us to round off to 1 decimal place, to 2 decimal places, and now the question wants us to round the answer off to 3 decimal places. So let's start. The process will be much in the same. Just when we take out the square root of the final calculation, we'll see that it comes to proper correct to 3 decimal places. So now, see, looking at the equation, it's already in the standard form. So a is equal to 3, b is equal to minus 12, and c is equal to minus 1. So the discriminant becomes minus 12 whole squared minus 4 into 3 into minus 1. So we have 144, and minus becomes plus, plus 12, which is equal to 156. Let us see what we can get. If we try to take out the square root of 156, we get so it is 2 root 39. We'll just remember that. So now x is equal to minus of b plus or minus the root of the discriminant by 2a. So x will be equal to minus of b, since b is minus 12, minus of b becomes 12, plus or minus the root of 156 divided by twice of a, which will be 2 into 3. So this becomes x is equal to 12 plus or minus, just remember that the root of 156 is 2 root 39 divided by 6. Now to calculate this value in decimals, again we go back to our square root tables for the square root of 39. We see that the square root of 39 is, I'm so sorry, I just forgot about it. Yeah, it's 6.24. So we'll get 12 plus or minus, since it's 24, I get 8, 4, 6. So it is 12 plus 12.48 by 6. So if I add 12 to 12.48, I get 24.48 by 6, or, and a minus, I get minus 0.48 by 6. So here it is x is equal to 4.08, or x is equal to 0.08, minus 0.08. So x is equal to 4.08, or x is equal to minus 0.08. Since it said correct to 3 decimal figures, however, answer only came up till 2. So this is how we will calculate the solutions. Let's move on to the next equation. The next equation is x square minus 16x plus 6. So now what we do is, we take a as 1, since it is given b is minus 16, c is 6. So the discriminant becomes 16 minus 16 whole squared minus 4 times of 1 into 6. Now 16 squared is 256, and 4 into 6 is 24. So I get 232. Again, just for clarity's sake, we'll just try and calculate, if we can, by prime factorization. So this will be the square root of the discriminant. So we'll keep that in mind when we move ahead. Now, x is equal to minus b plus or minus the root of the discriminant by twice of a. So x is equal to minus of b, since b is minus 16, it becomes 16 plus or minus the root of 232 divided by 2 into a, which is 1, so 2. So x is equal to 16. Since you remember it is 2 root 58, let's just calculate the value of root 232 beforehand. So if it is root 58, we go back to our square root tables. Root 58 is given as 7.615. Now I multiply 2 to that, I get 0. So it is 16 plus or minus 15.230 by 2. So x is equal to, when I do 16 plus 15, I get 31.230 by 2, or if I minus, I get 0.770 by 2. In calculating both of these values, I will get 1, 5, 6, 3, 1, 5, or is equal to 0.385. So these two are the solutions for the given quadratic equation. Okay, let's move on to the next equation. The next equation says 2x square plus 11x plus 4 is equal to 0. Now, so a is equal to 2, b is equal to 11 and c is equal to 4. So calculating the discriminant is 11 squared minus 4 times of a into c. So we have 121 minus 4 into 16, 32. So 9, 11 minus 3 is 8. So the discriminant is equal to 89. Now x is equal to minus of b plus minus the root of the discriminant by twice of excuse me. So now minus b is minus 11, the root of 89 by twice of a, since it is 2, so 2 into 2. So x is equal to minus 11 plus minus the root of 89 in a table, it is equal to 89 is equal to 9.433 divided by 4. So if I add 9.433, I get minus 1.567 divided by 4. Or if I subtract, I get minus 20.433 by 4, which will be equal to minus 0.15 million 3 bar plus 6 million 9 times 1, or x is equal to minus 5.108. So these two, that is minus 0.391 or minus 5.108, are the solutions for the given quadratic equation. Let's see the next question. Now the next question, it just says solve. As you can see, 5D is the exercise right after we learn the method of solving the quadratic formula. But if such a question pops up in your exam, it does not matter. You can attempt it by any method until the question mentions the specific method that you have to use. But we will go ahead and we will only be using the quadratic formula to solve these problems in exercise 5D. Okay. So here we have x4 minus 2x square minus 3 is equal to 0. As you can see, this isn't a quadratic equation anymore. It's become a biquadratic since its degree is 4. So what I can do is, I will take, let x square is equal to y. I'll replace x square with y. Since x4 is the square of x square, I can write y square minus twice of y, since x square minus 3 is equal to 0. This is my new quadratic equation that I'll solve for the values of y. Then I'll substitute them in x and find the values of x. So now, in this equation, a is 1, b is minus 2 and c is minus 3. So the discriminant becomes minus 2 whole squared minus 4 times of a into c. 4 and minus becomes plus 12, which is equal to 16. So the discriminant is equal to 16. Now, x is equal to minus b plus or minus the root of the discriminant by twice of a. So minus of b, since b is minus 2, it becomes 2, plus or minus the root of 16 by twice of a, since a is 1, it is 2. Now 16 here is a perfect square. We can just write 2 plus or minus 4 by 2. Oh, sorry, I am writing x here. I'll just write down y, since the variable we are looking for is y. So y is equal to 2 plus 4 would be 6 by 2 and 2 minus 4 would be minus 2 by 2. So y is either equal to 3, y is equal to minus 1. Now, we knew that we took y to be x squared, which means x squared is equal to 3 or x squared is equal to minus 1, which means that x is equal to positive or negative root of 3 or x is equal to the positive or negative square root of minus 1. Since we know this is an imaginary number, we can just say that the values of x are positive and negative root of 3. This is how we will solve an equation when it is a biquadratic. We can substitute the square with another variable solve for that value and substitute the values in the end. So we'll move on to the next equation. Next equation is quite similar. So again we will say let y is equal to x squared. So x squared into x squared is x4. So we will say y squared minus 10y plus 9 is equal to 0. So a is equal to 1, b is equal to minus 10, c is equal to 9. Now the discriminant will be minus 10 squared minus 4 to 1 to 9. So we have 100 minus 36, which is equal to 64. So the discriminant is equal to 64. So your y is equal to minus b plus or minus the root of discriminant by twice of a. So y is equal to, since b was minus 10, it becomes 10 plus or minus the root of 64 by 2 into a, which is, so 10 plus or minus the root of 64 being 8 by 2. If you subtract 8 from 10, we get 2 by 2, or if we add 2, we get 18 by 2. So y is either equal to 1 or y is equal to 9. Now since in the beginning we took y as x squared, we can substitute y with x squared. We'll get x squared is either equal to 1 or x squared is equal to 9, which means x is equal to plus or minus 1 or x is equal to plus or minus 9. So here we have the 4 values. Since it was a power x4, we would get 4 values. Oh sorry, I wrote 9. The square root of 9 being 3. So either x is equal to plus or minus 1 or x is equal to plus or minus 3. Those are the solutions for the given equation. If you are confused, just try and substitute any one of these values, plus 1, minus 1, plus 3 or minus 3 into this equation, and you will see that it satisfies it directly. So let's move on to the next question. So this next question here may look confusing, but you are not supposed to get confused. Now see, it is x square minus x whole squared plus 5 into x square minus x plus 4 is equal to 0. So what we are going to do is, like the question earlier, we took x squared to be y. Here we'll take this entire expression x square minus x to be y. What use is it, you ask me? Let's see. Just see, x square minus x is equal to y. So we can replace it here as y squared. And here also it is x square minus x, so we can write 5 times of y plus 4 is equal to 0. Now we have a new quadratic equation in the variable y. So now a is equal to 1, b is equal to 5, and c is equal to 4. So the discriminant is b squared, that is 5 squared, minus 4 times of a and c. 5 squared being 25, minus 4 into 4 is 16. So we get the discriminant as 9. So now y is equal to minus of b plus or minus the root of d by 2 times of a. So y will be equal to, since b is 5, we write minus 5 plus or minus the root of the discriminant 9 by a being 1, this becomes 2. So since 9 is a perfect square, we can just write plus or minus 3 by 2. Now if I do y minus 5 minus 3, we get y is equal to minus 8 by 2. Or if we do minus 5 plus 3, we get minus 2 by 2. So either y is equal to minus 4 or y is equal to minus 1. The problem, however, doesn't end here. We took y to be something, so we'll solve it for that. Now x square minus x is equal to minus 4, or x square minus x is equal to minus 1. Now we have two separate quadratic equations to be solved for the values of our variable. Here it is x square minus x plus 4. So again a is equal to 1, b is equal to minus 1, and c is equal to 4. The discriminant being b square minus 4 times of ac, which will be equal to 1 minus 16 and minus 15. Now since the discriminant is minus 15, we cannot solve this equation any further. We'll just leave it here. So the roots here will be imaginary since the discriminant is less than 0. How do I know that? Well, if you haven't watched a conceptual video of quadratic equations, you won't be able to get anything that we are doing here. So I'll request you to please go to our channel or go to the link in the description below. Watch the conceptual lesson of quadratic equations. Apart from that, we also launched another video that was the solutions for exercise 5A, 5B, 5C from Selina. So please watch that video as well. The link will be given to you in the description below. Apart from that, I would like to inform you that our channel Medha Guru is a place where a lot of teachers of excellent quality work together to make your education better. We have teachers, dedicated teachers for science, maths, SST and also English and computer. So please follow our channel and watch our videos to make your education better. So now coming back to the problem. So since the discriminant was less than 0, the roots were imaginary. We'll try and solve this version of the equation. So we'll get that A is 1, B is minus 1 and C is 1. So the discriminant will be minus 1 squared minus 4 times of AC. Again it is 1 minus 4 which is minus 3. So D being minus 3, the roots here will also be imaginary. So all the 4 roots for x for this particular equation are all imaginary. Okay, now we'll move on to the next equation. The next question is x square minus 3x whole squared minus 16x square minus 3x whole squared, x square minus 3x minus 36. Again, we'll just take this x square minus 3x as another variable. Let us see. So we get y squared minus 16y minus 36 is equal to 0. What we are going to do here is we will solve this equation to get the values of y. We can solve this by factorization as well. We'll say y square minus 18y plus 2y minus 36 is equal to 0. So y minus 18 plus 2 into y minus 18 equal to 0. So y plus 2 to y minus 18 is equal to 0. By the product rule, zero product rule, y is either equal to minus 2 or y is equal to 18. Now we took y to be something. So we get x square minus 3x is equal to minus 2 or x square minus 3x is equal to 18. Solve these equations separately, we will get x square minus 3x plus 2 is equal to 0. From where a is 1, b is minus 3, c is 2. The discriminant will be equal to minus 3 whole squared minus 4 into 1 into 2. As this is 9, minus 4 into 2 is 8, we get 1. So x is equal to minus of b plus or minus the root of the d divided by twice of a. So x is equal to minus b being 3 plus or minus the root of 1 by twice of a is 1, so 2. So x is either equal to 3 plus 1 by 2 or 3 minus 1 by 2. So x is equal to 4 by 2 or x is equal to 2 by 2, which means x is equal to 2 or x is equal to 1. This is we got from this equation. Now we have to solve this equation as well. Get x square minus 3x minus 18 is equal to 0. So a is equal to 1, b is equal to minus 3, c is equal to minus 18. From here we will get the discriminant is minus 3 whole squared minus 1 into 4 into minus 18. Then 9, minus and minus becomes plus, 18 into 4 is, this is equal to 81. So x is equal to minus of b, b being 3, plus or minus the root of 81 by twice of a 2. So x is equal to 3 plus or minus 81's root being 9 by 2. So 3 minus 9 by 2 is minus 6 by 2 and 3 plus 9 by 2 is equal to 12 by 2. So either x is equal to minus 3 or x is equal to 6. So for this equation, all the values of x that will be satisfied are 1, 2, 6 and minus 3. So these are all the values that we will get for x based off of this equation. Let's move on to the next question. So in this next question, it says solve root over x by x minus 3 plus root over x minus 3 by x is equal to 5 by 2. There are two ways to go about this. You take the square and you do a lot of hodgepodge, or what I am going to do is I'll take this root of x by x minus 3 as y. Then as you can see here, it is x minus 3 by x, which is nothing but that's reciprocal. So we can say that let y is equal to root of x by x minus 3, which means the equation will be y plus, as this is the reciprocal, it becomes 1 by y 5 by 2. So you get y square plus 1 by y is equal to 5 by 2. So 2y square plus 2 is equal to 5y. And so 2y square minus 5y plus 2 is equal to 0. We have this equation here, we can solve it by splitting the middle term into 4y, minus 4y and minus 1. We take 2y common, we get y minus 2. We take 1 common, we get minus 1 common, y minus 2. So either 2y minus 1 into y minus 2 is equal to 0. Which means 2y minus 1 is equal to 0 or y minus 2 is equal to 0. So y is equal to 1 by 2 or y is equal to 2. Now for these values, we will solve the value of x. So now since we know that y was equal to root over x by x minus 3, it is either equal to 1 by 2 or it is equal to 2. So taking the square on both sides, we will get x by x minus 3 is equal to 1 by 4, since the square of 1 is 1 and square of 2 is 4. So I multiply this, I get 4x is equal to x minus 3. I bring x to this side, it becomes 3x is equal to minus 3. So x is equal to minus 1. This is one solution. And from here again, if we take the square, we get x by x minus 3 is equal to 2 squared 4. So x is equal to 4x minus 12. Bring this to this side, I get minus 3x is equal to minus 12. Cutting this off, I get x is equal to 4. Right? So these are the solutions for x for the given quadratic equation. Moving on to the next equation, we have 2x minus 3 by x minus 1 minus 4 times of x minus 3 by 2x minus 1, x minus 1 by 2x minus 3 is equal to 3. Again, as you can see, we are supposed to use the same logic, since this term or this term is the reciprocal of that term. So what we will do is let 2x minus 3 by x minus 1 be equal to y. Then we have the new equation as y minus 4 by y, since this is 1 by y, is equal to 3. So y square minus 4 is equal to 3y. As I take the LCM y and take y to the other side, it becomes y square minus 3y minus 4 is equal to 0. I can factorize this by splitting the middle term as such. Now I take y as common, I get y minus 4, plus 1 as common, I get again y minus 4 is equal to 0. Now y plus 1 is equal to y plus 1 into y minus 4 is equal to 0. So either y plus 1 is equal to 0 or y minus 4 is equal to 0. Which means y is equal to minus 1 or y is equal to 4. Now we will substitute these two values to our original substitution that we took. So 2x minus 3 by x minus 1 is equal to minus 1 or 2x minus 3 by x minus 1 is equal to 4. Here we will get 2x minus 3 is equal to 1 minus x. We bring 3 to this side and x to this side. We get 3x is equal to 4. X is equal to 4 by 3. This is one value for x. Now for the other value, we will solve 2x minus 3 is equal to 4x minus 4. I bring 4 to this side and take 3 to the other side. I get minus 2x is equal to minus 4 plus 3 minus 1. So x will be equal to 1 by 2. So these are the two values for x for the given equation. Let's move on and look at the next question. Now the next question is also similar. It has a term, it has its reciprocal added and 5 by 2. So again, we will take 3x plus 1 by x plus 1 to be y. So we have y plus 1 by y is equal to 5 by 2. So we get y square plus 1 by y is equal to 5 by 2, which means 2y square plus 2 is equal to 5. Y gets multiplied there, and we have 2y square minus 5y plus 2 is equal to 0. Here we can also factorize it as 2y square minus 4y minus y plus 2 is equal to 0, making the equation look as, taking 2y as common, I get y minus 2. Taking minus 1 common, I get y minus 2. Now I have 2y minus 1 to y minus 2 is equal to 0. So either y is equal to 1 by 2 from this, or y is equal to 2 from here. So now I substitute these values back to the original equation. 3x plus 1 by x plus 1 is equal to 1 by 2, or 3x plus 1 by x plus 1 is equal to 2. Solving these independently, I get 6x plus 2 is equal to x plus 1. Taking x to this side and 2 to the other side, I get 5x is equal to minus of 1. So x is equal to minus 1 by 5. This I got from the value 1 by 2. From here, from the value of y being 2, we will get 3x plus 1 is equal to 2x plus 2. Taking 2x to this side and minus 1 to the other, I get x is equal to minus 1. So these are the two values for the variable x for said equation. Let's move on to the next question. The next question is, solve the equation 2x minus 1 by x is equal to 7. Write your answer correct to 2 decimal places. So we'll try and solve this. Now since the equation is given in such a form, it's not a quadratic yet, so we'll put it into the standard form. 2x minus 1x by 1 by x is equal to 7. So I take the LCM as x, I get 2x squared minus 1 is equal to 7. So 2x squared minus 1 is equal to 7x. And 2x squared minus 7x minus 1 is equal to 0. So a is equal to 2, b is equal to minus 7, and c is equal to minus 1. From here, we go out by calculating the discriminant, which is b squared minus 4 times of a into c. So we have 49, minus minus becomes plus 8, which is nothing but 57. So the discriminant is 57. Now x is equal to minus of b plus or minus the root of the discriminant by twice of a. Excuse me. So x is equal to minus b, b being minus 7, it becomes 7 plus or minus the root of 57 by twice of a is nothing but 2, so 2 into 2, which means x is equal to 7 plus or minus the root of 57, we'll see 2 by 2, 2 into 2 is 4. So again we don't have a perfect square root for 57, as 57 is not a perfect square. So I go back to my square root tables, I get that the square root of 57 is equal to 7.54. So now if x is equal to 7 plus or minus 7.54 divided by 4. So if I take 7 plus 7, I get 14.54 by 4. Or if I take 7 minus 7.54, I get x is equal to minus 0.54 by 4. From here, I'll get x is equal to 3. Or x is equal to minus 0.13. So these are the two values rounded off to 2 decimal places for the variable x in this equation, that is 3.63 or minus 0.13. Let's move on to the next question. Now in the next question it says, solve the following equation and give your answer correct to 3 decimal places. That is what we are going to aim at here. So here we have the equation already in the standard form. So a is equal to 5, b is minus 3, and c is minus 4. The first step would be to calculate the discriminant, which is b squared minus 4 times of a and c. This is 9, and minus becomes plus, so 4 into 4, 16 into 5 is 80, which is 89. So the discriminant in this particular question is 89. Now, so x is equal to minus of b plus or minus the root of d by twice of a. Which means x is equal to b being minus 3, minus b becomes 3, plus or minus the root of the discriminant, that is 89, by twice of a being nothing but 5, so 2 into 5 is 10. Now x is equal to 3 plus or minus 89. Now the root of 89, since 89 is not a perfect square, again I need to get from the square root tables. From the square root tables I see that the root of 89 is given as 9.43 divided by 10. So 3 plus 9.43 would be 12.43 by 10, or 3 minus 9.43 would be minus 6.43 by 10. Since it is divided by 10, I just need to move the decimal places. So x will be equal to either 1.243 or x will be equal to minus 0.643. And since both are already in 3 decimal places, our answer is rounded off to what we needed it to be. And the values 1.243 and minus 0.643 are the values for the given quadratic equation. Let's move on to the next question. The next question Solve for x using the quadratic formula. Write your answer correct to two significant figures. Here it's very important to understand the significant figures does not mean the same as decimal places. It means the number should have two digits. If the two digits are both before the decimal place, does not matter. If one is before and one is after, does not matter. If both are after the decimal, does not matter. It should have two significant figures. Okay. First of all, we need to expand this equation to bring it into the standard form. So when I expand x minus 1 whole square, I get, since it's a minus b whole square, I get a square plus b square minus 2ab minus 3x plus 4 is equal to 0. Now x squared minus 2x and minus 3x becomes 5x and this becomes 5. Now I have a as 1, b as minus 5 and c as 5. So the discriminant is equal to minus 5 whole squared minus 4 into a into c, which is 5. So 25 minus 4 into 5 is 20. This will be 5. So the discriminant is equal to 5. Now x is equal to minus of b plus or minus the root of the discriminant by twice of a, which means x is equal to, since b is minus 5, 5 plus or minus the root of 5 by 2 times of a being 1 will be 2. So x is equal to 5 plus or minus, we don't know the root of 5, so we go back to our square root tables where it is given as 2.24 by 2. So now 5 minus 2.24 will give us 2.76 by 2, and 5 plus 2.24 will give us 7.24 by 2. So now we get the values, x is equal to 1.38 or x is equal to 3.62. Now these answers would have been right by themselves, but since we have to do it to correct two significant figures, we'll round it off to these two digits, as these are two significant figures. So x will be either equal to 1.38 will become 1.4, or x is equal to 3.62, which will remain as 3.6. So these are the two values for the given equation. X minus 1 whole square minus 3x plus 4 is 0. So let's move on to the next and the last question of this exercise 5D. So last question says, solve the quadratic equation x square minus 3 into x plus 3 is equal to 0, giving your answer correct to two significant figures. Again, it's two significant figures. So first of all, we'll just expand this equation. We'll get x square minus 3x minus 9 is equal to 0. It's already in the standard form as soon as I expanded it. So a is 1, b is minus 3 and c is minus 9. The discriminant will be b squared minus 4 into a into c. Excuse me. So 3 minus 3 squared is 9 and minus becomes plus. 4 into 9 is 36. So we'll write it as 45. So the discriminant is 45. X is equal to, as we know, plus or minus the root of minus b plus or minus the root of d by 2 into a. Now we'll just substitute all these values into this equation. We'll get x is equal to minus of b. B being minus 3, this becomes 3, plus or minus the root of 45 divided by twice of a being 2, this will become, a being 1, this will become 2. So 3 plus or minus. Now again, the root of 45 we do not know. So going back to our square root tables, we get 6.71 by 2. So if I do 3 plus, I get 3 plus 6.71 would be 9.71 by 2. And if I subtract 6.71 from 3, I get minus 3.71 by 2. So x is either equal to 4.85 or equal to minus 1.85. So these are the two values for x. But since we are supposed to give it to two significant figures, we'll round it off as 4.8. So 4.85 is 4.9, or x is equal to minus 1.9. Now rounded off to two significant figures, our solutions for the given quadratic equation would be 4.9 or minus 1.9. Now we will move on to the solutions of exercise 5E. Now let's begin the solutions of exercise 5E. Now in this exercise, we can use both the methods that we have learned, that is factorization and also the quadratic formula, depending on whether the equation itself is factorizable or not. If it is factorizable, we'll use the easy method of factorization. If it is not, we'll have to use the quadratic formula. So let's begin. First question says, solve which of the following equation. The first one being 2x by x minus 3 plus 1 by 2x plus 3 plus 3x plus 9 by x minus 3 into 2x plus 3. When you look at these three fractions, we see here the denominator is x minus 3, here it is 2x plus 3, and here it is x minus 3 into 2x plus 3. So if you take the LCM of these three, it will obviously be x minus 3 into 2x plus 3. Just a second, I'm sorry. Yeah. So now I'll be taking the LCM as x minus 3 into 2x plus 3, and since this is already here, so here it will be 2x into 2x plus 3. Then it will be 1 into x minus 3, and then 3x plus 9, and all this is equal to 0. Now we straight away take this term to the other side and it will become 0 as well. Here it will be 4x squared plus 6x plus x minus 3 plus 3x plus 9 is equal to 0. We see we only have one x squared term, we don't need to add or subtract there. Now we have 6x plus x plus 3x, which becomes 10x, and then minus 3 plus 9 becomes 6. Now we can divide this equation by 2 and we'll get 2x squared plus 5x plus 3 is equal to 0. Now we are supposed to solve this equation. So 2x squared plus 5x plus 3 is equal to 0. Now we can split the middle term as 2x plus 3x. Then we will get, taking 2x as common, we will get x plus 1, and here taking 3 as common, we will get x plus 1. Then we have 2x plus 3 into x plus 1 is equal to 0, which means 2x plus 3 is equal to 0 or x plus 1 is equal to 0. It means x is equal to minus 3 by 2 or x is equal to minus 1. So these are the solutions for the given quadratic equation. Let's move on to the next problem. So the next problem is 2x plus 3 whole squared is equal to 81. So first of all, we have to form the quadratic equation from this given itself. So we'll a plus b will do whole square. So it will be a square, which will be 4x squared plus b square plus twice of ab, so 2x into 3 is 6x into 2 is 12x is equal to, now I'll bring 81 to this side, it will become 4x squared plus 9 plus 12x minus 81 is equal to 0. Simplified, that equation will be 4x plus 12x minus 72 is equal to 0. Now we can divide this entire equation by 4, we will get x square plus 3x minus 18 is equal to 0. Now we are supposed to solve this equation. Again here this equation is factorizable, that is we can split the middle term. So we will do x squared plus 6x minus 3x minus 18. Right, 6 plus 3 gives us, 6 minus 3 gives us 3, and 6 into minus 3 gives us minus 18. So we will take x as common, we will get x plus 6, and then here we will take minus 3 as common, again we will get x plus 6. So x minus 3 into x plus 6 is equal to 0, which means x minus 3 is equal to 0 or x plus 6 is equal to 0. So x is equal to 3 or x is equal to minus 6. And these are the solutions for the given quadratic equation. Now moving on to the next problem, we have a square x square minus b square. Here in this particular question, you don't even need the concepts of quadratic equation. You just need to have maths in your brain. So if I am supposed to solve this equation, it is a square x square minus b square is equal to 0. What I'll do is I'll just take b square to the other side. It's a square x square is equal to b square. Now I'll take a square to this side. Since here there is nothing written, it's multiplication. So when it goes to the other side, it becomes the division. So b square minus a square. Or we can write it as b by a whole square. If the bases are different and the power is same, we can apply a whole power. So now we just have to take the square root of this term to find the value of x. And since it is a squared, we can directly take out the square root as plus or minus b by a. And that will be the solution for the given quadratic equation. Now let's move on to the next problem. Now the next problem says x square minus 11 by 4x plus 15 by 8. We can solve this problem taking this as b and this as c, or we can multiply this 8 to this whole equation to form proper, there will be no fractions present in that equation. So what I'll do is I'll just multiply this equation by 8. If I multiply 8, I'll get 8x squared minus 8 into 11 by 4x plus 8 into 15 by 8 is equal to 0. Since 0 into 8 is always 0. So this 8 and it get cancelled and this becomes twice. So now we have a new equation that looks like 8x square minus 22 plus 15, 22x plus 15 is equal to 0. Now I have to split this middle term minus 22 as such that its sum is equal to minus 22 and the product is equal to 120. That is a positive 120. Now since the product is positive, I know this has to be broken down into two negative terms. So write it down again. 22x plus 15 is equal to 0. So what I'll do is I'll break this 22x into 10x minus 12x plus 15 is equal to 0. Since minus 10 and minus 12 give us minus 22 and multiplying them we get positive 120. So here I'll take 2 as common, 2x as common, I'll get 4x minus 5. And then here I'll take minus 3 as common, again I'll get 4x minus 5. So 2x minus 3 into 4x minus 5 is equal to 0. So 2x minus 3 is equal to 0 or 4x minus 5 is equal to 0. So x will be equal to 3 by 2 or x is equal to 5 by 4. These will be the values for x for the given quadratic equation. Now moving on to the next question. Now the next question is x plus 4 by x is equal to 4. So first things first, we need to form a quadratic equation out of the given. So what we'll do is we'll just take the LCM as x here. So we'll get x squared plus 4 by x is equal to 4 since this is x by 1. Then taking x to the other side we get x square plus 4 is equal to 4x, and bringing 4x to this side we get x square minus 4x plus 4 is equal to 0. Now we are supposed to solve this equation. If you look at the middle term, it is minus 4 and the product of a and c is a positive 4. So we can do that by splitting it into minus 2x and minus 2x. Then we will get, taking x as common, it will be x minus 2, and here we will take minus 2 as common, again it will be x minus 2. So we have x minus 2 into, x minus 2 into x minus 2. So this will be x minus 2 whole squared, which is equal to 0. So both the roots of this equation are going to be the same, that is x is equal to 2. Both the roots of this equation are 2 since they are real and equal. So these are the solutions. If it's not clear, I'll just write 2 comma 2. Now it's clear there are two roots which are same, because if we had gone by the way of solving by quadratic formula, we would have seen, just pay attention here, I'll just show it to you. So here a is 1, b is minus 4 and c is 4. Just to calculate the discriminant for once, we have b square, which will be 4 square, that is 16, minus 4 into a into c, and 4 into 4 is nothing but 16. Since the discriminant is 0, we would, even by that method we would see that the quadratic equation would have real and equal roots. Now how do I know this? I know this because there are some concepts related to quadratic equations, and if you don't know that, means you haven't yet watched our video on the basics of quadratic equations. So please go to our channel or go to the video in the link in the description and watch that video first. Also, we have already launched a video of the solutions of Selina's Concise Mathematics exercises 5a, 5b and 5c. So go to the description and find a link for that video as well. Apart from that, Medha Guru is a home to a lot of teachers of great quality, teachers of English, SST, Science and so on. So please subscribe to our channel and join the family today. Coming back to our question. So now that this question is over, let's move on to the next question. Now the next question is 2x to the power 4 minus 5x squared plus 3. Now this may not look like a quadratic equation, and it's not, because it is a biquadratic equation. Since the highest power, that is the degree of the equation, is 4. So what we will do is, we will substitute some values such that this equation becomes a quadratic and we can solve it easily. What we will do is, we will take another variable y to be as x square. So if we replace x square with y, we will get 2y squared. Since y squared will become x to the power 4, and that's what we have here. 5y plus 3 is equal to 0. Now here 2 into 3 is 6, that is positive 6. So we will just split this into 2y minus 3y plus 3 is equal to 0. From which you get, if we take 2y as common, we get y minus 1. And here we take 3 as common, we get y minus 1, minus 3. So now we have 2y minus 3 into y minus 1 is equal to 0. Which means y is either equal to 3 by 2 or y is equal to 1. And we say, hooray, the problem is over. But as you remember, we took y to be some value, that is x squared. So the problem isn't over yet. We have to still solve this. So now we know that y is equal to 3 by 2 or y is equal to 1. And we took y as x squared. So x squared is equal to 3 by 2 or x squared is equal to 1. Simply taking the roots, we can say these are the 4 solutions. Since it was a biquadratic equation of power 4, these are the 4 solutions for the given biquadratic equation, where x can be either positive or negative the root over 3 by 2, or x can be a positive or negative 1. So that's how we solve such questions. By taking x squared to be some other variable, we deduce the equation down to a quadratic, which we know how to solve, because solving a biquadratic equation is much tougher. So let's move on to the next question. Now in the next question, the similar thing is happening, that we have x to the power 4. So again, we will take a variable, this time let's take z to be x squared. So the new equation formed will be z squared minus 2z minus 3 is equal to 0. So this is the new equation, and luckily for us, it's in the form of a quadratic equation. So that is what we know how to solve. So we'll start by splitting this middle term, that is minus 2z into 3z plus z. Since minus 3 plus 1 is equal to minus 2 and minus 3 into 1 is equal to minus 3, which is also a into c. So here I'll take z as common, I'll get z minus 3, and here I'll take 1 as common, z minus 3 again. So z plus 1 into z minus 3 is equal to 0. So either z is equal to minus 1 or z is equal to 3. So these are the values for z. However, just like the earlier case, this is not the solution for the given equation. Now we took z, the variable z, to be x squared. So we'll replace z with x squared in both places. When z is equal to minus 1, which means x squared is equal to minus 1, or x squared is equal to 3. Now if we have to take out the square root, which means we have to take out the square root of negative 1. And as you may all know, this is what we call an imaginary number. So here the square root of the value of x is a negative minus 1. And since we know such numbers do not exist, we can say that in this case, there are no real roots for x when x squared is equal to minus 1. When we took x squared as minus 1, there are no real roots for x. Now we solve it here. So x will become the positive or negative square root of 3. So these are the values for x, that is the real values for x, which satisfy this biquadratic equation. Since when we took x squared to be minus 1, it is impossible to find roots for x, since minus root over minus 1 becomes an imaginary number. So the only possible values that we can find for x for this particular equation, that is x to the power 4 minus 2x squared minus 3, are the positive and negative square roots of 3. So now let's move on to the next question. Now in the next question, it's kind of complex. You have to understand the details of it first. Here we have 9x squared plus 1 by x squared minus 9x plus 1 by x minus 52 as 0. Here as you can see, here we have x squared plus 1 by x squared, and here we have x plus 1 by x. So straight away it would strike to you that we should take this as y and this as y square. However, you may miss out that this is not completely y squared if this would be y. But the thought process is on the right track. We'll take x plus 1 by x as y. Let's see what happens. So we take y as x plus 1 by x. What happens when we square y? We're supposed to square the other side as well. So if I take out the square of x plus 1 by x square, we'll get x squared. That is, if we see it as a plus b, we get a square plus b square plus twice of a into b. Now since a is x and b is 1 by x, these both will cancel out among each other, and we'll be left with x square plus 1 by x square plus 2, which is nothing but y square. Now since we have x square plus 1 by x square here, we'll leave that and bring 2 to this side. So x square plus 1 by x square will be equal to y square minus 2. This is how we'll deduce a value based off of another variable for this entire expression. So if you see such problems pop up, always remember the formula of a plus 1 by a whole square, which you also learned in class 8 and class 9 in the chapters expansion. So just keep that formula in mind. Now since we have the values for x plus 1 by x and x square plus 1 by x square, we'll just substitute these values into the original equation. So we have 9 into x square plus 1y square being y square minus 2. We'll write it down as y square minus 2 minus 9 times of y, since x plus 1x is y, minus 52 will be equal to 0. Now, opening the bracket, we have 9y square minus 18 minus 9y minus 52 is equal to 0. You can write as 9y square minus 9y minus 70 is equal to 0. Now here we have a into c forming minus 630. And that is how we are supposed to split minus 9 into. So we split it into minus 30y plus 21y minus 70 is equal to 0. Since minus 30 plus 21 will give us minus 9, and multiplying these both we get minus 630. So we'll take 3y as common here, we'll get 3y minus 10. And taking 7 as common here, again we get 3y minus 10. So 3y plus 7 into 3y minus 10 is equal to 0. Then y will be equal to minus 7 by 3, or y is equal to 10 by 3. Now here I am going to erase the board. So before that, you can pause the video and write down everything we have here. Just remember that y is either equal to minus 7 by 3 or y is equal to 10 by 3. And the fact that we took y as x plus 1 by x. We are on a shortage of space here, so I'll just rub the board. So you can pause the video here and copy down everything. So since y is equal to minus 7 by 3 or it is equal to 10 by 3. Now we know y was x plus 1 by x. And we got the values of y as minus 7 by 3 or y is 10 by 3. Now since we know what y is, we'll just write x plus 1 by x is equal to minus 7 by 3 or x plus 1 by x is equal to 10 by 3. So it will be x square plus 1, bring this 3 up here, we get minus 7x. So 3x squared plus 7x, bringing 7 to this side, plus 3 is equal to 0. And here we have x squared now here we can solve by factorization. Clearly it is 3x square minus 10x, which we can write as 3x square minus 9x minus x plus 3 is equal to 0. Take 3x as common, we'll get x minus 3, and here we'll take minus 1 as common, we'll get x minus 3. So 3x minus 1 to x minus 3, from which we get x is equal to 1 by 3 or x is equal to 3. So we have 3 and 1 by 3. But this is not the end. We have another equation for x. Now we are going to solve this one by the quadratic formula. Since 3 into 3 is 9 and 7 cannot be broken down into two positive numbers such that the product is 9. So we'll just say the discriminant is b squared minus 4 times of AC. AC is 9 into 4 is 36 and we have 13. So now we have the discriminant to be 13 and I'll solve the rest. I'll be solving over here. So x is equal to minus of b. Now since b is 7, minus of b will be minus 7 plus or minus the root of 13 by twice of a being 3 here, we'll take it as 6. Now again, since root 13 is not a perfect square root, it's not a perfect square, we'll go back to our square root tables from the book itself and we'll see the value for square root 13. Here I can see that the square root of 13 is equal to, just a second, square root of 13 is 3.61. So we have x is equal to 7 plus 3.61 by 6 or x is equal to minus 7 minus 3.61 by 6. In this case it will be equal to minus 3.39 by 6 or x is equal to minus 10.61 by 6. 5, 6. So the values here will be minus 0.56 and minus 1.06. 6. And these are the 4 possible values for x for the original equation. Now we'll move on to the next one. So now the next question is 2 times of x square plus 1 by x square minus x plus 1 by x is equal to 11. Now this question is quite similar, or it's quite identical to the earlier one. So this one I won't be solving. However, I want you to solve it and let me know in the comments down below what the possible values for x for this given equation are. We'll be moving on to the next problem. Now the next problem is slightly different. Here we have x square plus 1 by x square, which was just like the earlier two. Then we have x minus 1 by x. So you'll be in a dilemma. If we take y as x minus 1 by x, what will y square be? Let's see for ourselves. We say, this time I want to take z as x minus 1 by x, just for a change. So square of z will be x minus 1 by x whole squared. So expanding this as a minus b whole squared, we will get a square plus b square minus 2ab. Again x and x is cancelled out. So we have x square plus 1 by x square minus 2. Now we just want x square plus 1 by x square. So we'll take 2 to the other side. It becomes x square plus 1 by x square is equal to z square plus 2. And like earlier when it was minus 2, this time it will be z square plus 2. So now we'll substitute our values, known values, into the equation. We have x square plus 1 by x square, which we found to be z square plus 2. Then we have 3 times of z. So z is x minus 1 by x minus 2 is equal to 0. Now clearly you can see here we have a plus 2, then we have minus 2. So we cancel them out. We have z square minus 3z is equal to 0. Taking z as common, get z minus 3. So either z is equal to 0 or z is equal to 3. These are the possible values for z, not for x. Now we are supposed to find the values of x based off of these two values. Now when z is equal to 0, which means x minus 1 by x is equal to 0. So x is equal to 1 by x, which means x square is equal to 1. Then we can take the square root of x, which will become plus or minus 1. Up here we will just be writing all the values of x which we get. So it is x is either plus 1 minus 1. This is based off the value that z was 0. Now again we will come back to x minus 1 by x is equal to 3. So x square minus 1 is equal to 3x. Since taking the LCM 3 and I took it to the other side. X square minus 3x minus 1 is equal to 0. Again here there are no possible values to break down minus 3 into such that we get a sum of minus 3 and a product of minus 1. So we will solve it by the quadratic equation where d will be b squared, that is 9, minus 4ac, and since this is 4 it becomes plus. So again we have the discriminant as 30. Then we will take x as minus b, which is 3, plus or minus square root of 13 divided by twice of a, which is 2. Now since I do not know the value of square root of 13, since 13 is not a perfect square, again I go back to my square root table, from which I find out that the square root is 3.61, from which we get x is either equal to minus 0.61 by 2 or x is equal to 6.61 by 2. So x is equal to minus 0.30 or x is equal to 3.30. Yeah, so the values are 3.30, the last one is minus 0.3. So these are all the possible values that x can have for the given condition or for the given quadratic equation. Now let's move on to the next question. Now the next question is also sort of a substitution way, that we have to solve it by substitution, but it's a bit more complex. I want you to see very carefully what I'm going to say. We have two trinomials being multiplied to each other, and both of them are quadratic in their own sense. This and this are both quadratic. So what I want you to concentrate on is this part here, which is x square plus 5x. It is common to both these trinomials. So what I am going to do is, I'll just say let x square plus 5x is equal to a. So now my new equations will be a plus 4 into a plus 6 is equal to 120. So now I substituted x square plus 5x as a, from which I got a plus 4 into a plus 6 is 120. So when I multiply both of them, I get a squared plus 10x plus 24 is equal to 120. Now I bring 120 to this side, I get a square plus 10x minus 96 is equal to 0. I have to solve this equation such, that is break down 10 into such that the product of the coefficients is minus 96 and the addition is plus 10. So I can do that by 16x minus 6x minus 96 is equal to 0. Taking a as common here, I get a plus 16, and taking minus 6 as common here, I wrote a. These all need to be as a, I'm just sorry. So a plus 16. So a minus 6 into a plus 16 is equal to 0, which means a is either equal to 6 or a is equal to minus 16. End of the problem, kids? No. Now we took a to be something in terms of x. Now we will try to solve x based off of these two values. So first, when a is equal to 6. So x square plus 5x is equal to 6. So we will write x square plus 5x minus 6 is equal to 0. Second. Yeah. So I'll split the middle term into 6x minus x. And we'll get x plus 6 minus 1 plus 6. So x minus 1 to x plus 6 equal to 0. X is either equal to 1 or x is equal to minus 6. Again, I'll be writing all the values of x here. We have minus 1 and minus 6. Now this is when a was equal to 6. Now we have another value for a which is minus 16. So x square plus 5x minus 16 is equal to minus 16. So I bring minus 16 to this side, we get x square plus 5x plus 16 is equal to 0. Again, if you look at this equation here, we have the middle coefficient, that is x coefficient, to be 5. And since the product is positive, we cannot break down 5 into two positive numbers such that the product gives us 16. So we will solve this equation by quadratic formula. So we have the discriminant, which is b squared, so 25, minus 4 times of ac. Now a into c is 16, and 4 times of 16 will be 64. And this is equal to minus 41. And if you remember well from the concepts of quadratic equation, if the discriminant is negative, that is less than 0, we have a quadratic equation that has no real or equal roots. So the only values for x that are acceptable for us are 1 and minus 6, since this will not give us any real roots. So let's move on to the next question. Next question, it says solve each of the following equations giving answer up to 2 decimal places. As soon as you read this word up to 2 decimal places, it should strike to you that we are supposed to solve these equations by the quadratic formula. Even if you don't understand why, you may try and see, but what we will notice is that when, for example, if you look at this equation right away, a is 1, d is minus 5 and c is minus 10. If I am supposed to solve by factorization, which means I have to break down minus 5 such that I get two coefficients that add up to minus 5 and multiply to minus 10. So the product of a and c is minus 10. But here we will see that it is not possible to break down minus 5 such that its coefficients give us an addition of 5 and a product of minus 10. So we have to solve such equations when the question mentioned giving answer up to certain decimal places, 1 decimal place, 2 significant places, 2, 3 decimal places, which you will do good to remember what is the difference between decimal and significant places. So if the question is asking such, we know we have to solve these equations by the quadratic formula. So let's begin. We have a as 1, b as minus 5 and c as minus 10. First things first, let's calculate the discriminant. The discriminant is b squared, which is 25, minus 4ac. Since c is minus, we will put a plus, and 4 into 10. That's the second, b squared minus 4ac. Yeah, so we have the discriminant as 65. Now we are supposed to solve, which is minus b. We'll just write the formula once just to remember. This is the quadratic formula. So we'll just substitute the values of whatever we know. So we know minus b. Since b is minus 5, minus b equals 5. And the discriminant is 65. Since a is 1, we'll just write. So x is equal to 5 plus or minus. Again, 65 isn't a perfect square. So we'll just see our square root tables for the value of 65, root 65, which we find to be as root 65 is 8.06. So it is 8.06 by 2. X is either equal to minus 3.06 by 2 or x is equal to 13.06 by 2. So we get x to be as minus 1.53 or x to be as 6.53. So these are the two values for x for the given quadratic equation, and we rounded them off to 2 decimal places each. So now let's move on to the next question. The next question is 3x square minus x minus 7. Again, if you look at it, 3 into minus 7 gives us minus 21. There are no way that you can split minus x into two coefficients such that they add up to minus 1 and the product is 21. So what we'll do is we'll start solving by the quadratic formula itself. So we can see that a is 3, b is minus 1, c is minus 7. So the discriminant is b squared, that is 1, minus 4 times of 3 into minus 7, which will get cancelled as plus. So we have 1 plus 4 into 3, 12 into 7 will be 12 sevens are 84. The discriminant came out to be 85. Now we'll just apply the quadratic formula. Excuse me. Minus of b, since b is minus 1, it will become 1. Plus or minus square root of 85 divided by twice of a, since a is 3, this becomes 6. So x is equal to 1 plus or minus, Now since 85 isn't a perfect square, we see our square root tables and find out that square root of 85 is 9.22. So x is either equal to minus 8.22 by 6 or x is equal to 10.22 by 6. If you don't know why, it's 1 minus 9.22 once and 1 plus 9.22 once. So this will be equal to minus 1.2213 or x is equal to 1.427. So these are the possible values for x for this quadratic equation. Now let's move on to the next equation. The next equation is, you have to solve this equation for the values of x. Now this is x by x plus 2 whole square minus 7 x by x plus 2 plus 12. Again, it is possible to solve this equation straight away, or else we can substitute x by x plus 2 to be some other variable. So we'll take it as, let's say a is equal to x by x plus 2. Makes sense? So now we'll do, the new equation is a square minus 7a plus 12, which is equal to 0. Now here we have a new quadratic equation in terms of a. Now we can solve this by any method we like. We can solve it by factorization or we can solve it by quadratic formula. Here however, as a into c is 12 and the middle term is minus 7, I can solve it by factorization. I can divide it into minus 4a minus 3a. Since minus 4 plus and minus 3 add up to minus 7 and the product is equal to positive 12. So here I take a as common, I get a minus 4, and here I take minus 3 as common, again I get a minus 4. So a minus 3 into a minus 4 is equal to 0. So either a is equal to 3 or a is equal to 4. These are the values for a, but our equation is not in a. Since we took a to be some value, we will find all the values of x based off of both these. So when a is equal to 3, x by x plus 2 is equal to 3. So x is equal to 3x plus 6. Since I multiplied this to the other side, I bring this to the other side, it becomes minus 2x is equal to 6. So x is equal to minus 3. So when a was 3, x was minus 3. Now when a is 4, x by x plus 2 is equal to 4. So x is equal to 4x plus 8. Again I bring 4x to this side, I get minus 3x is equal to 8. So x is equal to minus 8 by 3. So these are the values for x for this particular equation. Now let's move on to the next problem. Now in the next problem, again we have to find the solution of this quadratic equation. But after we are done finding the solution, we are supposed to see which of them are natural, since x for this equation is only an element of natural numbers. What you need to understand here is that this quadratic equation, or all quadratic equations, always have two solutions. But in some cases, the solutions do not apply to us. That we will be seeing when we will be covering the next chapter, that is word problems based on quadratic equations. But more of that when we get into that chapter. Here all we need to concentrate on is, we solve this equation, we get the values, and we check which of them are given from the replacement set, and which of them belong to this set, here the case being natural numbers. So first of all, without paying attention to this, we will just try and solve this equation first. So we have x square minus x minus 12 is equal to 0. So the middle term, that is b, is minus 1, and we have a into c as minus 12. So we can solve this if we split the middle term into minus 4x plus 3x. Since adding them gives us minus 1, the coefficients, and multiplying the coefficient gives us minus 12. So I'll take x as common here, x minus 4, plus 3 as common here, again x minus 4. So x plus 3 into x minus 4 is equal to 0. So either x is equal to minus 3 or x is equal to 4. And these are both solutions for the given quadratic equation. However, our solution is supposed to be from the set of natural numbers. Now we know that minus 3, although it's a solution for this equation, it's not a part of natural numbers. So this root will not be qualifying for our answer. However, 4 is a natural number. So we will say that x is equal to 4 based off of this condition here. So did you understand? So in this type of questions, you are supposed to find all the solutions for x, because always it will not be a quadratic. Like some of the examples, like some of the problems we solved were biquadratic, where we substituted some values for x square. So we will be getting 4 values for x in those, right? If there is a replacement set given, it does not change the process as such. We are supposed to find all the roots or solutions for that equation, but then we will strike out, or we will filter only the solutions that pertain to our given condition. Did you understand? Okay, so we'll be moving on to the next question. Now in the next question, it's quite similar. It says x square minus 4x minus 12 is equal to 0, such that x is an element of I, which are integers. So now, first things first, we'll just solve the equation, because that has nothing to do with this solution. We'll just find the solution, and then we'll check which of them are integers. So now I have the middle term as minus 4, and the product of a and c as minus 12. So I'll split the middle term into minus 6x plus 2x. Since minus 6 plus 2 gives us minus 4, and minus 6 into plus 2 gives us minus 12. So here I take x as common, it takes minus 6. And here I take 2 as common, again I get x minus 6 is equal to 0. So x plus 2 into x minus 6 is equal to 0. X is either equal to minus 2 or x is equal to 6. Now I write down x is equal to, now I have to pay attention to our condition here, that x should be an element of integers. Since both the values that we have arrived at are integers, we can write both of them down, and both will qualify for our given condition. This will not always be true, but if it is, we can write both the solutions for our equation. Okay, now let's move on to the next question. The next equation is 2x square minus 9x plus 10 is equal to 0, where x is an element of q, which are rational numbers. So again, we will just solve the equation first, then we will see which of these values belong to this replacement or superset. So, we have 2x squared minus 9x plus 10 is equal to 0. So I'll split it into minus 5x minus 4x. Since adding both of this gives us 9, minus 9, and multiplying both of these give us 10 into 2, which is 20. So yeah, here we'll take x as common, which gives us 2x minus 5. Here we'll take minus 2 as common, which will again give us 2x minus 5. So we have x minus 2, 2x minus 5 is equal to 0. Means x is either equal to 2 or x is equal to 5 by 2. Now these are the values for x for the given quadratic equation. However, we are supposed to find values which belong to rational numbers. And we see both of these values are rational numbers because both can be expressed in the form P by Q. So we will say directly that x is equal to 2 or 5 by 2. And these will be satisfying our condition where x is an element of rational numbers. Now let's move on to the next question. So the next question says, solve this equation a plus b whole square x square minus a plus b x minus 6 is equal to 0. So now our a, that is the coefficient of x square, is a plus b whole square, the coefficient of b is a plus b, the coefficient of c is minus 6. So there are two ways to go about this. If you go about by solving this by, let's say, factorization, it's not going to be a simple process. So what we will do is we will solve this by the quadratic formula. You may think it's going to be very complex, but stay with me, bear with me. So we have a is a plus b whole squared, b which is minus of a plus b, and c which is minus 6. The discriminant is b square minus 4ac. So we'll write the discriminant as b squared. Since minus a plus b and a plus b will have the same square, we'll just say a plus b squared. Now minus 4 into ac, minus 4 into c minus 6 into a plus b whole square. Now since minus and here there will be a minus will become plus, we can say 4 into 6 into a plus b whole square. So this is 4, and if you don't understand, this was minus 6 which made it plus. So now we have a plus b whole square plus 24 times of a plus b whole square, which gives us 25 times of a plus b whole square. Now to put it into the quadratic formula, that is minus b plus or minus the root of d divided by twice of a. So x is equal to, since b is minus of a plus b, we will just write a plus b plus or minus the square root of 25 a plus b whole squared and twice of a, which is a plus b whole squared. Now since 25 and a plus b whole square both are actual squares, that are the perfect squares, we can directly take out the square root as, this will be just a plus b plus or minus 5 times of a plus b divided by twice of a plus b whole square. Now we solve both these roots separately. The first one being a plus b plus 5 times of a plus b by 2 times of a plus b whole squared. It means x is equal to 6 times of a plus b divided by twice of a plus b whole squared. We'll cut this off with the square. This will go into 3 times. So x is equal to 3 by a plus b. So this is one root for x based off of when we did a plus b plus 5a plus b. When we do it minus, we will get, just see, 1 minus 5 will give us minus 4 times of a plus b. Down under we have 2 a plus b whole squared. So this square again gets cancelled and this goes 2 times. So x becomes minus 2 times of minus 2 by a plus b. So 3 by a plus b and minus 2 by a plus b are the solutions for the given quadratic equation. So now let's move on to the next question. So now the next question is 1 by p plus 1 by q plus 1 by x is equal to 1 by x plus p plus q, and we must solve for x. So we'll begin. On the left hand side, we'll take the LCM of the fraction, which will be p into q into x, and we'll go ahead like that. So we have, taking the LCM as pqx, we have qx plus px plus pq is equal to 1 by x plus p plus q. Then what we'll do is we'll multiply pqx here and then x plus p plus q here. So we get x plus p plus q into qx plus px plus pq is equal to pqx. Now to expand the left hand side, I need to multiply x with all the terms, p with all the terms, and q with all the terms. So we'll get x into qx, which will be qx squared, then x into px, which will be px squared, and then x into pq, which will be pqx. Then when I multiply p here, I get pqx This side will be PQX as usual. Then P into PX will be P square X. Then P into PQ will be P square Q. Then Q into QX will be Q square X. Q into PX will be PQX. And Q into PQ will be PQ square. So this entire algebraic expression is equal to PQX. Now we have plus PQX on both sides, we will cut it off. So now we are left with, I'll take the x square terms together, the x terms together, and then the rest of the terms together. So I get Q plus P x square plus P square plus Q square plus 2PQ times x, and then we are left with P square Q and PQ square. So P square Q plus PQ square, which is equal to 0. So we equated the equation up till here. Now as you can see, this is P plus Q, and here if you look at this very carefully, it is P plus Q whole squared. So we'll write it down like that. We'll get P plus Q x square from here. Then we formulate this to P plus Q whole square x, and then if we take out PQ common here, in the bracket we get, if we take out PQ from here we get P, and from here we get Q, is equal to 0. Now as you can see, all these have a coefficient of P plus Q in them. So what we will do is we will divide this entire equation by P plus Q. Then we will get x squared plus P plus Q x plus PQ is equal to 0. Which means the new equation is x square plus Px plus Qx plus PQ is equal to 0. What I just did is just a representation of what we mean by when we say split the middle term. So now I'll take x as common here, it will be x plus P. Then I'll take Q as common here, again it will be x plus P is equal to 0. Which means x plus P into x plus Q is equal to 0. Which means x is either equal to minus P or x is equal to minus Q. So these will be the solutions for the given equation. Let's move on to the next question. The next question, the first part is x into x plus 1 plus x plus 2 into x plus 3 is equal to 42. So first things first, we'll open the brackets. It will go like x square plus x, plus if I multiply this becomes x square plus 3x plus 2x plus 6 is equal to 42. So you have 2x squared plus 6x plus 6 is equal to 42. Now we can divide this entire equation by 2. We will get x squared plus 3x plus 3 is equal to 21. And if we bring 21 to this side, we get x squared plus 3x minus 18 is equal to 0. Now we are supposed to solve this equation x squared plus 3x minus 18 is equal to 0 for the solutions. So we split plus 3 into plus 6x minus 3x such that plus 6 and minus 3 added give us plus 3 and multiplied they give us minus 18. So we will take x as common here, I get x plus 6. Then take minus 3 as common, again I get x plus 6. So x minus 3 into x plus 6 is equal to 0. So x is either equal to 3 or x is equal to minus 6. And these are the solutions for the given equation. Let's move on to the next one. Next question says 1 by x plus 1 minus 2 by x plus 2 is equal to 3 by x plus 3 minus 4 by x plus 4. So now let's try solve this one. So on the left hand side, clearly the LCM is x plus 1 into x plus 2. And here the LCM is x plus 3 into x plus 4. So multiply this here, you get x plus 2 minus twice of x plus 1. Similarly here it is 3 times of x plus 4 minus 4 times of x plus 3. So here we get x plus 2 minus 2x minus 2 by x square plus 2x plus x plus 2, get x squared plus 4x plus 3x plus 12, and up here we get 3x plus 12 minus 4x minus 12. 2 and 2 gets cancelled and we get minus x by x square plus 3x plus 2. And here we have 12 and 12 gets cancelled, we have minus x by x square plus 7x plus 12. We can cancel out the minus x's on both sides. Now we multiply this here and this here, we get x squared plus 7x plus 12 is equal to x squared plus 3x plus 2. Now as you can see, x square is on both sides of the equation. We cancel it out. Now we take 12 to the other side and bring 3 here. We get 4x is equal to minus 10. So x will be equal to minus 10 by 4, which is minus 5 by 2. And this is how we will solve this particular equation. Let's move on to the next one. The next question says, for each of the given equations, we must find a value of m so that the equation has equal roots. Also find the solution of each. If you remember in the earlier video when we learned the basics of quadratic equation, we learned something known as the discriminant, which helps us to judge how a discriminant can help us to judge the nature of the roots of a given quadratic equation. We'll go by that logic. So first things first, we'll calculate a, b and c. Given to us is a is m minus 3, b is minus 4 and c is 1. Now the discriminant is b square minus 4 times of ac. Now b square being 16, which is minus 4 squared is 16, into 4 into m minus 3, and c is 1, so there is no point of writing it down. So we have 16 minus 4m minus 12, which is 16 minus 4m plus 12, which gives us 28 minus 4m. Now according to the question, it says that the equation has equal roots. And we remember the condition for an equation to have equal roots is that the discriminant must be equal to 0. So we say that 28 minus 4m, which we calculated was the discriminant, is equal to 0. Which means 4m is equal to 28. Which means that m is equal to 7. So if the value of m is 7, only then will this equation have equal roots. So what we are going to do is now we have to find the solution of this equation. So you substitute the value of m into the equation, we get 7 minus 3 x squared minus 4x plus 1 is equal to 0. So we have 4x squared minus 4x plus 1 is equal to 0. Now we must divide or separate this minus 4 into two coefficients such the product should be a positive 4 and the sum should be minus 4. So we write 4x squared minus 2x plus 1 is equal to 0. Here we take 2x as common, we get 2x minus 1. And then we take minus 1 as common, again we get 2x minus 1. So we have 2x minus 1 into 2x minus 1 is equal to 0. It means x is equal to 1 by 2. Twice of 1 by 2, since we already knew that the equation had equal roots. Let's move on to the next part. Now the next part says for this equation, that is 3x squared plus 12x plus m plus 7 is equal to 0. Again, we will begin by taking the values of a, b and c. Again, first things first, we will calculate the discriminant. Square of 12 being 144 minus 4 times of 3 into m plus 7, which gives us 144 minus 12 into m plus 7. So this is 144 minus 12m minus 84. Oh sorry, plus 84, which I open the bracket, it becomes minus 12m minus 84, which will be 60 minus 12m. And again, the question said that this equation had equal roots. So we can equate that this discriminant, which we found to be 60 minus 12m, must be equal to 0, which means 60 is equal to 12m, and therefore m will be equal to 5. Now again, we will substitute the value of m and we will solve our equation. So we get 3x squared plus 12x plus we substitute the value of m, get 5 plus 7 is equal to 0. So 3x squared plus 12x plus 12 is equal to 0. So now we have the quadratic equation and we are supposed to solve it. So 3 into 12 will be 36. So we will divide plus 12x into such that the coefficients add up to a positive 12 and give a product of a positive 36. Excuse me. 6x plus 12 is equal to 0. So here we will take 3x as common, we will get 2x plus, sorry, we will take 3x as common, we'll get x plus 2. And then again we take 6 plus 6 as common, we again get x plus 2. So the two equations we have are 3x plus 6 into x plus 2 is equal to 0. So x is equal to either minus 6 by 3 or x is equal to minus 2. And when we equate this, x is equal to minus 2 comma minus 2, which you already knew based off of the question that the roots were going to be equal. So now let's move on to the next question. So the next part says x square minus m plus 2x plus m plus 5 is equal to 0. Again, we take the values of a, b and c. Calculate the discriminant and we know that it is going to be 0. So what we do is b squared, which will be m plus 2 whole squared. Since minus m plus 2 and m plus 2 whole squared will give us the same answer. So 4 into 1 into m plus 5. So we have m squared plus 4m plus 4 minus 4 times of m minus 20. So minus 4m and 4m gets cancelled, and when we do that we get m square minus 16 is equal to 0. Now this came 0 from the fact that we know that it has equal roots, so the discriminant must be equal to 0. So we have m square is equal to 16, so m will be equal to 4. Now we substitute the value 4 into this equation and then we will try and solve it. So substituting 4 we get x squared minus 4 plus 2 is 6x plus 4 plus 5 will be 9. So this is the quadratic equation that we must solve to get our answer. Now we have to divide minus 6 such that the product is a positive 9 and its sum is minus 6. So we divide it into x square minus 3x minus 3x plus 9 is equal to 0. So we take x common, we get x minus 3. Then we take minus 3 common, again we get x minus 3. So the equation is x minus 3 into x minus 3 is equal to 0. So x is equal to 3 comma 3. And these will be the equations, the solution for the given quadratic equation. And based on the question we knew that they were going to be equal. So now let's move on to the next question. Now the next question says, without solving, find the value for p in which the roots are equal. Again we are supposed to find a value for p such that the roots of this quadratic equation will be equal. Again a is equal to p, b is equal to minus 4 and c is equal to 3. According to the question, if the roots are supposed to be equal, the discriminant must be equal to 0. Which means b square minus 4ac must be equal to 0. Now b is minus 4, so b squared will be 16. 4 into AC is equal to 0. So we have 16 minus 12p is equal to 0. So we take 12p to the other side, we get 12p is equal to 16. We cut it off by 4 on both sides, we get p is equal to 4 by 3. So the value of p for this particular equation to have equal roots will be 4 by 3. So now let's move on to the next question. Now the next question says, without solving, find the value for m for which the roots are real and equal. Again we are supposed to do the same thing. We are supposed to find a value for the variable m such that this given equation has real and equal roots. So we'll start by a is 1, b is equal to twice of m minus 1 and c is equal to m plus 5. Now the condition for this equation to have equal roots is that the discriminant must be equal to 0. So we'll substitute the value of the discriminant, that is b square minus 4ac. So now I'm going to substitute all the values up here. So it becomes 2 into m minus 1 whole squared, right, because of b square, and 4 into 1 into m plus 5. Now this discriminant must be equal to 0. So we get from here 4 times of m square plus 1 minus 2m minus 4m minus 20. Since 4 into m is 4m and 20. Now we have 4m squared. Or what we'll do is we divide this equation by 4. We get m square plus 1 minus 2m minus m minus 5 is equal to 0. Which gives us m square minus 3m minus 4 is equal to 0. Now we'll solve this quadratic equation by splitting minus 3 into two coefficients such that the product gives us minus 4 and the sum gives us minus 3. So we'll get minus 4m plus m minus 4. We take m as common, we get m minus 4. We take 1 as common, we get m minus 4. So m plus 1 into m minus 4 is equal to 0. So m is either equal to minus 1 or m is equal to 4. And these will be the possible values for m for which the given quadratic equation will have equal real and equal roots. So kiddos, that brings us to the end of today's video lesson. So the next video, that is the solution of exercise 5F, which is a miscellaneous exercise from all over the book, that is from all of quadratic equations. I have a surprise planned for you for that video. So please subscribe to our channel Medha Guru today and turn the notifications icon on so that you can be notified when that video comes out. Apart from that, please check out our channel for the other subject teachers like SST, chemistry, biology, physics and so on. And until the next video, I'll see you soon. Namaste.